How are we doing this Monday morning? If you brought your computers, go ahead and bust them out because we're going to be looking at Scratch again. Um, in fact, just bring your computers until further notice. See if you play. And if you didn't bring one, don't worry about it. Um, so, how was the weekend? Any any exciting things happen? Huh? You existed. That's good. We're also still here. Haven't gotten sent away. Um, okay. Some Star Wars. Yeah. What about you guys online? What'd you guys do this weekend? Who do we have online? Mr. Hall, Farden. Yeah. All right. Well, let's get to it. Um, we've got a bunch to talk about today. A couple things. This is going to be a very busy week for us because, in addition to our first Scratch project, which we'll talk about in a moment, the details. Uh, what are you going to have to do sometime this week? Huh? Yeah, some kind of test. Okay, so you're going to do uh, your basic skills exam. I'll set it to unlock sometime Wednesday. I have to finish writing it. And then you can take it any time between then and, uh, say, Sunday night. Um, just find a good hour or so that you've got to do it. We normally would do these sorts of things in class, but we'll just use the computer. Um, it's supposed to be closed book, so don't make me be a jerk and not trust you guys. You would be amazed the kind of logs that Canvas keeps about what you click and when, uh, and I can get to all that. It's amazing. I can find out exactly what kind of device and which web browser you're using and what IP address you had when you did it. It's really cool. So don't make me go all stalker NSA on you. Anyway, um, right. And then the way this will work is that if you can retake this thing uh, in the subsequent 3 weeks, uh, once per week kind of thing. And if needed. But it'll be good preparation for the final. So there's that. We'll also have our first Scratch project due Sunday night. Um, try and give you guys the weekend so you have some time to polish it off. Which the first one, regardless of whether or not you want to do something in Minecraft for the second one, uh, I'd like you for the first one. I'd like everybody to use Vanilla Scratch for that. And basically, what we're going to do is, I think I showed you guys at the last time. Imagine the little intros from video games or Hollywood, right? At the beginning of you fire up a game or you fire up a movie, and there's the little animations that tell you what studio or studios made it, and it looks kind of cool, and they're over in maybe 10 to 30 seconds, right? So that's basically what you guys are going to make. Uh, and for your imaginary game development studio, whatever you want to call it, so I'll upload the actual, exact specifications to YouTube. I mean, to YouTube, to Canvas. But basically, the things that it needs to have are you need to have some sort of logo. Okay, and you can build that out of sprites that are built into Scratch. I'll show you kind of some of the stuff that's there. Um, some motion, some audio, some animation. Well, I already said motion, and then it needs to fade to black or fade to some solid color at the end. Doesn't have to be black, but I'll show you how to do it for black. Um, and other than that, just make it creative and kid friendly because Scratch is supposed to be G-rated, so you could be creative and have a little fun with it, but don't make it too naughty. Anyway, so all right, let's get to the Scratch stuff then. So let me just let's start creating something. So what do you guys want to make? Let's make a simple animation of some sort. What? Well, here, let's get rid of this stupid cat. Let me go to the sprites and show you just. Let's look at kind of what you have at your disposal. It's lots of animals and people and kind of cartoony stuff, but you do also have letters and numbers in sort of three different stylized fonts, and you can put those together, obviously, to make some sort of. Oh, I'm sorry, guys at home. I forgot to switch back to Chrome. You can obviously put those together, and you'll notice that I'm hovering over one of them. Um, that those are all different costumes. So this bottom set, right? You can alternate between the different costumes to get kind of a cool looking effect. So we'll use those for our just sort of plain thing. Why don't we have it say like CS101 and the letters can come from all over different places? How's that sound? All right, so what that means is we're going to need this part kind of sucks. That what we need is basically each of the letters is an individual sprite. Um, oh, that's lame. They don't have the numbers in the last category. They only have the numbers here. Well, we'll just do CSC, whatever. That's sufficient to get the idea. Okay, so first thing I need to do is decide, well, how do we want this thing to look? Let me just put the letters, drag them around um, into some sort of rough position, and we can make more precise exactly where they are in two ways. So you see here, you've got X and Y coordinates, right? So the origin of the screen is at the dead middle. That makes sense. And then X runs horizontal, Y runs vertical. So we can make really precise exactly where these things are going to go. We'll figure out exactly where we want them to go in a minute. So a couple things we can do. Let's see, what do we have for the costumes? We've got multiple costumes, and we can animate between them. Um, so let's see. Hmm. Well, why don't we have the S? Let's put that at the origin. Okay, so it's dead middle. And then the C's, let's put those at Y. And then how about, let's say, negative 100. Oops. I don't know, maybe that's too far. Yeah, that looks good. At this point, I'm just making something up, right? It doesn't have to be anything particularly special. Okay, so we now know where they want to appear. So let's look here in the motion tab. What different options do we have for how things move? Well, there's quite a bit of stuff, right? So we can have move by so many steps. A step is basically like a pixel unit length, and so you can have things sort of move. You can turn them by however many degrees. You can go to a random position. That's going to teleport them. Basically, it's instantaneous. Or you can go to a specified set of coordinates. Uh, you can use this thing called glide. I would avoid using glide though, because um, particularly if Well, like let's say we were programming a game where you had like a moving object and the goal was to click it while it was moving. If it's gliding and you click it, like where it's halfway through the glide, it doesn't detect it. The glide like takes, so let's say you make a glide take a second. Uh, it takes a second and it doesn't register anything else while it's moving, which is annoying. Okay, so don't use the glides; it's a bad idea. Point in directions. We can also point towards wherever the mouse pointer is, which again can be kind of useful in a game kind of context. You can change X and Y by specific amounts. And if you do that repeatedly with the loop, then that's how you can make something look like it's moving in a kind of fluid manner. Um, and then these guys here allow you to get the position of the object, uh, its coordinates, so that you could do math with it, for example. Okay. Um, so um, yeah, so the shapes here, so you see the blocks that have like the little notch on the top and bottom. Those are execution blocks and they stack to make a program. The little roundy dudes are numbers that you would then use as part of a formula or some other thing. Uh, and yeah, I think that's it there. Okay, so one thing we could do is let's uh, let's take this first C, okay? And when does everything happen? Well, it happens, when does stuff start? Okay, so the program will start running when you hit the little green flag, okay? And so we could, let's just use that as our start. Um, and what do I want this C to do? Well, let's see. Why don't I have it move to someplace random, and then I'll have it move to the correct position on the screen. Uh, yeah, sound good? Okay. Okay, so if I have it go to a random position and I run this, right, each time I'm clicking the green button, it's randomly running, or it's running the program again, and that moves the thing to a random position on the screen. Okay, so what do we want to do with it? We want it to move to the correct spot, which has coordinates what? Negative 50 comma 0 was the spot we picked. Okay, nothing special about that location. Um, so how are we going to get it to move from wherever it is to negative 50 comma 0? Well, there's a couple things I could do. All right, I could do the glide, but like I said, I don't want to do that. Okay. Um, so if I'm not going to use the glide, basically the only option I have is to change the x and the y coordinates by some amount. Okay. Um, all right, well, let's do some math then. If it starts at some random position and I needed to end up at negative 50 comma 0, well, how long do I want it to take to get there? Well, that's also up to me, right? But I need to calculate almost like a slope kind of thing. Okay, so right now, where is it? It's at some y coordinate. What is it? It happens to be negative, or sorry, x coordinate, happens to be negative 77, okay? And it happens to be at y equals 97, okay? So I want a function that's going to do some math and get me from negative 77 to 0, or in the x direction, and then from 97 to, sorry, I said that wrong. From negative 77 to negative 50 in x, but 97 to 0 in y. Okay, does that make sense? Yeah. All right. So, how can we do this? Well, let's um, let's make a variable. Let's make two variables actually. Um, all right. Now, when I make a variable, um, there are two options that appear. Okay, for all sprites and for this sprite only. So what's the difference? I mean, the name kind of indicates it, but why is that make sense that there's a difference? Okay, so let's think about this from the standpoint, let's say you were programming a game, like how about a tower defense game? Okay, and you're going to have like, let's say the first wave, you've got like 50 orcs that come rolling through, right? Well, what should each orc have, say? I mean, come on, guys. You've played tower defense games, haven't you? Yeah, they're going to have some sort of hit points, right? So your towers are going to shoot them. They're hopefully going to all die, but your tower isn't just going to nuke all 50 of them and bam, it's done, right? Like, it's the first level of your tower defense game, so you probably have some lame arrow tower or something that's going to go pew pew, right? Huh? Dart monkey? I was going to say, which tower defense game are you playing? Balloon? Oh, I don't think I know this one. All right, well, let's just have a peek then, shall we? Balloon. Balloons tower defense? Uh-huh. Oh, is this like an on browser? Ah, okay. So, how many hours of high school did you guys waste playing these things? Okay. Uh-huh. So, there was this game when I was in high school that people would play, particularly so like my English composition class, which would be, kind of like English 101 here. Um, sort of same idea. Um, we met in a small room that had computers in it, so you could, we could do writing exercises and stuff. Well, the way the room was laid out, it was like in a big rectangle, and there were computers around the perimeter, uh, three of the four sides of the big rectangle. But then there was a big table in the middle that had computers facing outwards. Okay, so if you were at the center table and the professor was on the other side of the table, she could not see your screen, right? And I can still remember I had the same professor both semesters, uh, Dr. Schofield. I wonder if I think she's still teaching. She was great. Uh, anyway, the game that everybody would play, I think it was called Jez Ball. Yep, that's it. Um, so basically, the idea was it would you would click a button and a little wall would appear, and you'd try to have to like contain all the let me see if I can find a video of it. It was like that. And so the thing was though, as the wall was expanding, if one of the balls hit it, then you lost, right? So you had to time it, right? And then it got progressively harder. Yeah. Anyway, so where I happened to sit was on the outside of the rectangle, and so always in between me and the professor was some douchebag playing this game, and it was very distracting when you're trying to talk about, Shakespeare or Voltaire or something, right? Um, yeah, read a lot of interesting things in that class. Um, all right. Well, anyway, so the difference here on the variables would be um, if, like, let's say we had your orcs and your tower defense, each orc needs to have its own independent health. And let's say that you call the variable health. If I make this global, then there is one variable called health, and that's it. If I make it, so global means for all sprites. If I make it local, that means it only is attached to that individual sprite. And if I had like 50 of them, each one would have its own individual value of that variable, even if they all have the same name. Okay, so so in this case, we actually do want this thing to be for this sprite only. Okay, because what I'm going to make this variable, I'm actually going to make two of them, and we'll call it desired x and desired y, meaning where do we want the things to end up. Okay, and by making it a variable, what about if I decide later, you know, I really don't like it at negative 50 comma 0. I really want it at negative 25 comma 30. Then all I have to do is change the starting value of those variables. I don't have to change any of the other formulas. All of it will recompute automatically. Okay, so that's the power of using variables for stuff, is you don't have to redo it. Okay, so I'll call this desired x, and then I'll make another one called desired y. And you'll notice that by default, variables are displayed up at the top in your preview palette. And how do you know which sprite they're attached to? The name of that sprite goes before the colon, right? So I've got story C, who has variable desired x and desired y, and their default values are 0 because I haven't set them to be anything yet. Okay, good. Huh? Did you make it for this sprite only? That's why. Okay. So yes, so if you make it, if you don't select for this sprite only, then that means it's a global variable, and you'll probably have to delete it and start over. Okay. Okay. Now I'm going to have to do the same thing for the S and the other C, but you guys get the idea. So I'll just worry about one letter. Okay. Okay. So if we go to a random position, and I want to get from um, one place to the other, what I basically need to compute is what's the difference in the x coordinates and what's the difference in the y coordinates. Okay. All right. So how could I do that? Well, oh, by the way, if you want to make them not be shown at the top, you can just unclick here. I'll go ahead and leave them clicked. All right. So two things we need to do. Where do we want the thing to end up? We want it to end up at, say, negative 50, 0. Okay, so at the very beginning of the program, I'm just going to set the value of the variable to that thing, and then we'll continue. Okay, all right, so it is currently at where? Negative 77. And I want it to end up at negative 50. So what's the difference of those two things? Okay, well, it depends on which order we subtract them in, right? Okay, so what I want to do is I want to do the desired one minus the current one. And the reason I want to do it in that order is because that way I don't have to worry about the plus or minus. It'll sort itself out. Okay, so what I want to do is, let's see, so let's do some math. Let's do desired x minus actual, or x minus desired x. Okay, so this number right here, if I computed it, would be, it's currently at negative 77, and I want it to be at negative 50. So what's negative 50 minus negative 77? 27, right? Negative 50 minus negative 77. Yeah, 27. Okay. So that means that and that makes sense, right? It needs to go 27 units to the right to get the correct position. All right, let me just take that thing and I'm arbitrarily going to divide it by 100. Okay. Um, and I'm going to make a new variable. Let me call this one delta x. Okay, so I'm going to divide it by, 100. So you can stack these things, and it's a little hard to probably see this on the screen, but can you see that there's a little real thin black border around the x position minus desired x? Maybe it's maybe not visible on the screen, particularly for you guys at the back. But uh, why am I pointing that out? Well, who am I dividing here? Am I dividing the difference by something, or am I only dividing the desired x by something? Which way do I want it? The whole difference. Okay, now, in textual programming or in math class, how would you make clear which one you meant? Huh? Parentheses, right? Aren't grouping symbols great? But you know what we don't have here? Parentheses. That kind of sucks. Okay, so the order in which you nest these things into the sockets kind of determines the order of operations. Like I said, you guys probably can't see this on the screen, but the this guy has a little black border around it, which means it's a single object. Okay. All right. So let me just, I'm arbitrarily going to divide this thing, by 100. And I'm going to set the value of the variable delta x to this number, okay? And I'll do the same thing for y, okay? Except, well, first off, I need to make a variable called delta y. Okay, and I'm going to set this variable to basically the exact same formula, except instead of x position and desired x, I'm going to use y position and desired y. Okay, so same idea, just for y instead of x. Okay. Oh, and this should not be change delta x, but rather set delta x, or sorry, delta y. Okay, so now I've um, done that. Okay, now one thing is kind of important here about the order. Why do I have those two blocks after the go to random position and not before? Yeah, so it needs to go to a random position, and I want to know what the x and y location of that random position are. So if I did this before the go to random position, it's going to be all jacked up because who knows where my sprite is. Okay. Okay. Now let's actually get the movement going. So what the way I'm going to make this animate is I'm going to make a loop. Okay. And I'm going to repeat until something happens. Okay. All right. So what should happen here? Well, what do I want to do to make my sprite move from one place to the other? How about I have it move just a little bit, and then a little bit more, and then a little bit more? Make sense? Okay, so I'm going to repeat until it's in its correct position. Okay, so how do I tell if it's in its correct position? Well, when do I know it's in the correct position? when the actual x coordinate and the desired x coordinate are the same number. And same thing for the y. Okay? So what that means is I need to do some logic here. All right, so I want two things to be true. Okay, so hence I'm going to have an and. And why are these guys, like, notice their shape? I think we talked about this. It's probably been a few weeks. But why do they have little pointies? Okay, so what's the pointy data type here? Well, what can you and together? True and false, right? So the pointies indicate that this is a true-false type object, okay, or a Boolean. Okay, good. All right, so what is it that we want to be true? We want the variable desired x to be equal to the variable actual x, okay? And similarly, I want the variable desired y and the actual y position to be the same thing. All right, and I want both of these things to be true. So I'm going to repeat something until the thing is where I want it to be. Okay, does that make sense? Okay, so now what goes on the inside of the loop here? Huh? No, not the random position. It's already in the random position. I need to do something that makes it move, right? Which means what I need to do is change x and y by some amount. All right, now if I just plop those blocks in, it says 10. Okay, that's not what I want, obviously. How much do I want to change x and y by? Well, if only I'd made a variable for this. How about delta x and delta y? That's why I called them delta x and delta y. Yeah? Okay. All right, so let's replace the 10s there with the variables delta x and delta y. Run it and see what happens. Delta x, huh? And delta y. All right, so let's run it. Here, let me get rid of these variables so that we can actually see. Well, that doesn't look like it's working. In fact, it looks like it's moving exactly the opposite direction from what I want. Okay, so why is that happening? Well, let's look at the value of the variables. Did I subtract them in the wrong order? Maybe? Well, all right, let's think about it. So oh, that's why. No, wait. X position. Yeah, I subtracted them in the wrong order. Okay, so let's just take the C. Let me drag him here. Okay. All right, where is he? He's at negative 91. What's the desired x? Negative 50, right? So if I do negative 91 minus negative 50, I get a negative number. Yes? And then I divide by 100. So if I add a negative number, the x coordinate of the thing is going to become more negative. Well, that means it's moving opposite of the direction I want it to. Okay? So what do I need to do to fix this? Just flip the order of subtraction here and here. All right, now let's try it. Bam. Okay. And in fact, here, let's do something kind of fun. Um, there we go. All right, you guys won't be able to hear this because I don't have it. It's on. It's going to come through my AirPods. But all right, so run it again, and I hear it playing a cheer sound. Okay. All right. So does that kind of make sense? All right. Now, how could we tweak this? Like, any ideas for how we can make it different or modifications? Yeah.
How would you get the C to change?
Change like the oh, how it looks. Ah, okay. So we had noticed that the C had multiple costumes. Okay. So under looks, I have here, I can go to a specific costume or I can go to the next costume. So if I throw this in here, every time it moves, it'll switch costume. All right, this might be a little trippy. Um, okay, it was a little trippy because it was changing costume every time it moved, which was maybe a little bit too fast, right? So how could we slow down or speed up the movement? Couple ways we could do it.
The movement of the costumes,
Huh?
like the change of the costumes.
Well, or the movement, the actual movement itself.
Well, the you don't you change how much
Right. Okay, so that's one thing. So the quantity delta x, how did I define that? I made it the difference, but then I divided it by 100.
you divide by like.
Okay, so why did I divide it by 100? Yeah, okay, if I had only divided by 1, it would have gone bloop, and it would have looked like it just teleported to the new location. It would have only moved in one step. If I did divided by 2, it would have done it in 2 steps and so on, right? So if I want to speed up the rate at which it moves, I can just change that 100 to a smaller number. If I want to slow it down, I could change it to a bigger number. Okay, does that make sense? All right, now the other thing I could do is put in a very, very short time delay. Okay, and that's under control. Now, let me just use wait 1 second here, which is ridiculous. I wouldn't actually do this, but let's see what it does. Okay, so for two things are happening. It is changing costume, yes, and it is moving towards the target location, yes. It's just doing it really, really slowly. Okay, why is it going so dang slow? Because it's waiting an entire second each time. Okay, so how long is it going to take to get there? It's going to take 100 seconds. So, you know, minute 40. Huh? I mean, we could sit around and wait all day. So, 100 seconds was a little bit ridiculous. So, what would be better? Well, if I shorten this time delay, like let's make it a tenth of a second. Okay, that's not quite so bad, right? It is still animating. How long does it take to get to its destination? How long was that? Let me get rid of this sound because that's yeah. It should have taken 10 seconds, right? Because it takes 100 steps because I divided by 100, and each step was 0.1 of a second, so that's 10 seconds, right? All right, so maybe that was a little bit too slow still. So how about let's cut it in half and do like 0.05. Oops. All right. Well, at this point we're kind of it's artistic license which one we want. Okay, so how could we do this? Could we basically take this for and do it for all the other two, right? And so what would have to change? Yeah, that's it. Okay, so what I'm going to do is I'm going to duplicate this, and then this thing's kind of cool. I've got this thing called the backpack. Okay, and the backpack is kind of like a clipboard, so you can copy code back and forth between projects. But in this case, I can just take it and drag it, say, to the S, and you see how the S is sort of wiggled a little bit there? And then if I go to the S's code, it's there, and then I'll take this one and also copy him to the C, and then I'll get rid of the extra copy. Okay, so now the S and the C both have copies of this. Okay, but um, and when I did so, it made copies of the variables, right? So remember, delta x and desired x, and same thing for the y, were local to that sprite. So if you copy code over to a different sprite that has those variables in it, it's going to say, oh, he's copying a local variable. So I need to make a new local variable for the new sprite that has that name so that things don't get flubbed up. Okay, so it actually did a lot of that for us automatically. And so on the S, well, where do we want the S to end up? 0, 0. And where do we want the other C to end up? 50, 0. Okay, and so now let's run it. Okay, all right, why are the costumes different? Because they started at different things. And why did they start at different things? Well, because 100 isn't divisible by 3. Okay, so yeah, that's why. So how could we fix that, by the way? What we can do is we can tell them each to start with costume 1 at the very beginning. And that way they'll all start with the same costume, which means that at the end, they'll all end with the same costume. Okay, kind of cool. All right, it's both kind of cool and also probably a little kind of lame, but hey, you're not going to be making Borderlands 3 with this tool. Okay. So how many of you guys have played Borderlands 3, by the way? Anybody? PC or one of the scrub machines? PC, excellent. Yeah. Um, Epic or Steam? Steam, okay. Anybody else? No? All right. Um, so yeah, you can tweak this thing up all you want, right? Make it faster, make it slower. Well, what other things could we do here? Well, the sky's kind of the limit at this point. Okay, um, so what other things could we add here? What other ideas might we have? Right? Be creative. Let's just say, how would we do blah? And then we'll figure it out. Make it pulse. What do you mean pulse? Oh, okay. I see what you mean. Yeah, there we go. Okay. All right. Well, let's see. Let's go to the C. So pulse, I'm going to interpret that to mean size. And let's do another repeat. And I'm going to repeat this. Oh, no, wait, actually, I think I can just do it like this. Okay, let me do something like that. All right, so when it's finished, what the left C will do. All right, so you see how it got slightly bigger and then got slightly smaller again? Let me exaggerate the difference so that's a little bit easier to see. Okay, so the default size for these things is just whatever the bitmap that made them is, say 100%. And I can change the size by some amount. So if I set the size to 200%, then obviously the thing would be double. What I did here is changing the size by 50. If it started at size 100, I changed it to size, well, 150. And so I got not twice as big, just 1.5 times. Okay, well, good enough. Huh?
It goes like it stays at this.
It does stay at that.
It's like set size.
Okay, yes. So if it's when the program terminates, okay, it's the object is going to stay at whatever size it was at that moment. Okay, now here I've made it change the size and then change back. So it should get back to where it started after the program runs. Unless, what happens if during this 1 second wait, I hit the red stop button and I terminate the program early? Then it never goes back to its default size. Okay, so what I can do to fix that is up at the very beginning, I'll set the size to 100%. And that way, when the program starts, it starts at the correct size. This, by the way, would be how you would do something like, um, let's say that you wanted like lots of little C's and S's floating around. Maybe we'll add that next time. Okay, doing something kind of random. Then I can make them start at 10% size or whatever. Okay, um, and so you can get a lot of art. I mean, different objects out of the same art just by playing with the size. Okay, and so now it will return to its correct size, and I won't have any problems. Okay. Okay, so kind of makes sense what we've got here, and a lot of this, frankly, is just a couple things. You've got to decide visually, right? This is where you guys have some room for creativity. What do you want to make? How do you want to make it look? Okay, what sounds do you want to use? Music. Um, I had somebody, was it, I think last year they did like a Rick and Morty style animation that had the Rick and Morty music and like random stuff flying around, and all of a sudden there's a pickle that comes out of nowhere. I'm like, what the heck? And because at that point I hadn't actually watched any Rick and Morty, so it's just like, what is it? What are you smoking? But yeah, then it was pretty good. So yeah, I've seen some pretty cool ones here, but you know, it's not going to be as cool as say the 2K Games logo or something like that. But you've got a lot of stuff to do here. All right, so next time what we'll do is um, we'll talk about what are called clones and do some messaging stuff, which you can do some really, really clever things with. So, okay. Let me save this as something so that I don't lose this and we can pick back up next time. So let's say fall 2020 intro demo and save. Okay. All right. See you guys Wednesday.